Again, welcome to Precalculus. This is Mathematics 164 at NJCU. These lectures will cover chapter 2 of our course textbook, and that's quadratic equation, chapter 2-1. So our main objective is to learn how to solve quadratic equations with factoring methods. Also, how to solve quadratic equations with quadratic formula. So we start with the factoring method first. Again, these lectures cover our textbook, chapter 2, section 1. So here we say a quadratic equation in one variable is an equation that can be written in the general form as following. Again, always we know quadratic equation, the highest exponent or the degree is 2 squared. So if we have ax squared plus bx plus c, and a, b, and c will be values. So for example, a is the coefficient of x squared, b is coefficient of x, and c is a constant value. A can never be 0, because what will happen is that if a equal to 0, the equation will not be a quadratic equation no more. It will be a linear equation. And so it will be what we call the simple equation. A quadratic equation normally will give us a parabola form. The graph will be in the parabola. If we have bx plus c, if the highest exponent of the variable is 1, we get a straight line graph. If the highest exponent is 2, we get again parabola. So here we say where a, b, and c represent a constant value. For example, we have 3x squared plus 4x plus 1 equal to 0. This is a quadratic equation because the highest exponent, degree, is 2. Or we also have 2x squared plus 1 equal to x squared minus x. Also is a quadratic equation. We can bring the x squared minus x to the left side, and the equation will be equal to 0. We still have the highest degree to be 2, the variable. So here they say when we're solving the quadratic equation, we will be interested only in the real solutions or real number solutions. And we will consider 2 methods of solving it. First, we shall start with the factoring method, and the second, we will do the quadratic formula. So solution by factoring is based on the following property of a real numbers. So first, we should know the zero product property. Here we say for any real numbers, let's say a and b, a times b will give us 0 only if a is 0 or b is 0 or both of them is 0. So hence, to solve by factoring, we must first write the equation with 0 on one side. As we saw, again, we're going to see examples soon. As we saw this form, ax squared plus bx plus c equal to 0. Then we can factor the left side. So let's see an example. Again, here we are going to solve this quadratic equation using factoring. Y minus 3 times y plus 2 equal to -4. This is a quadratic equation. Why? Because if we open the parentheses here, we are going to get y squared. The highest exponent will be 2, so it's a quadratic equation. For example, here we get y times y, which will give us y squared. Then y times plus 2 will give us plus 2y. Then minus 3 times y will give us minus 3y. Plus 2y minus 3y will give us -y. So we get y squared minus y minus 6, because minus 3 times 2 is minus 6. So again, the highest degree is 2. So this is a quadratic equation. Also, when we look at b, we also have a quadratic equation. Why? At least I can see in one section we have x times 3x. So that will give me 3x squared. The highest exponent is 2 always for quadratic equation. So let's solve this equation by factoring. The first thing we need to do again is by removing the parentheses. Let's solve for the a. So we have y minus 3 times y plus 2 equal to -4. So we are going to, again, multiply y minus 3 times y plus 2. As we said, that will give us y squared minus y minus c is y, because y times y is y squared. Y times plus 2 will give me plus 2y. Then I also have minus 3 times y, which is give me minus 3y. They are like terms. We have minus 3y plus 2y. So we can combine them together, and that will give me minus 1y. We normally don't write the 1, so we just write minus y. Then the last one will be minus 3 times plus 2, which will give us minus 6, equal to minus 4. Now, if we are doing factoring, we always want to let the equation equal to 0. So we are going to bring minus 4 to the left side. So we get y squared minus 2 and also minus y equal to 0. Y, again, here we have minus 4. When minus 4 crosses the equal sign, it becomes plus 4. So plus 4 minus 6 will give me minus 2. So our final equation will be y squared minus y minus 2 equal to 0. Now here we can factorize now. Again, we went through basic college algebra, how to factorize trinomial. So I'm going to look for two numbers. When I multiply, I'll get -2. When I combine together, I'll get -1, because y coefficient is 1, -1 minus y. So minus 1y. And those two numbers will be minus 2 plus 1. So minus 2 times plus 1 will give me minus 2. Minus 2 plus 1 will give me minus 1. So y is minus 1y. So we get what we get, 1y minus 2 and y plus 1 equal to 0. So here we have y minus 2 equal to 0. And solve a simple equation, minus 2 will cross the equal sign, become plus 2. So our first y value will be 2. The second, we have y plus 1 equal to 0. Plus 1 cross the equal sign becomes -1. So y equal to -1. So our solution will be 2 and 1. Now we can plug the 2 in our equation and the 1, and we should get again the zeros by checking. So that's what we did here. And we go to the original equation. This is our original equation. So we plug the values for y's. And here we can see that when we plug the values, we have again 2. And we also plug 2, so we get -4. When we plug 1, -1, -1, we also get -4. Again, we check by using the original equation. So I'll plug -2. No, sorry, the answer was 2. So I plug 2 here and 2 here. The answer should give us -4. And the other answer was 1. We plug 1, 1, which I think is -1 or so. Let's see if it's -1. So we plug -1 and -1, we get -4. So let's try the second example. Here we said x plus 1 divided by 3x plus 6 equal to 3 by x plus 2x plus 6 divided by x times 3x plus 6. Now, the first thing we need to do is to find the LCD, since we have again, numerator and a denominator. The LCD here, as we look at the equation, will be x times 3x plus 6. So we know s times 3x plus 6 divided by 3x plus 6 will give me x. So I'll multiply x by x plus 1. Then also I have x, 3x plus 6 divided by x will give me 3x plus 6. So I'll multiply 3 by 3x plus 6. Then the last section, x, 3x plus 6 divided by x, 3x plus 6 will be 1. Then I'll get 2x plus 6. So let's go through the steps. So what we did is, as we said, the LCD will be x, 3x plus 6. So I multiply the x, 3x plus 6 by the whole equation here. equal to, again, we multiply x, 3x by 6 by the second equation. And the last one, the same thing. We multiply x, 3x by 6 by the equation again. So we have 3s plus 6 multiplied by everything here on the left side and the right side. Then we can cancel. So we saw 3s plus 6, we cancel 3s plus 6 left with x. So it will be s times s plus 1 equal to, here we have x, 3s plus 6 times 3 divided by x. So only the x will cancel. So we get 3 times 3s plus 6. And here we have s3s plus 6 divided by s3s plus. So they will cancel each other. Then it's left with 2s plus 6. And that's what we have here. The next step, we can remove all the parentheses. So when we remove the parentheses, again, let's go back. We get s times s, which will give me s squared. S times 1 will give me x. Then we have 3 times 3s will be 9x. 3 times 6 will be 18. 2s plus 6. Then we can combine the like terms. So for example, we get 3 times 6, which is 18, and 18 plus 6, which will give us 24. And here we have 9x plus 2s, which will give us 11x. And we have s squared plus x. And that's what we have here. S squared plus x equal to 9x plus 18 plus 2x plus 6. So now, as we said earlier, solving this equation by factoring, we are going to transform or basically move all the items on the right side of the equal sign to the left side. And we equate the equation to 0. So this is what we get. S squared minus 10x minus 24 equal to 0. First of all, s squared is by itself, so we have it down there. 9x plus 2x will give me 11x. When 11x cross the equal sign is positive, it becomes minus. So we get minus 11x plus x, which will give me minus 10x. Then here we have 18 plus 6, which is 24. 24 is positive. When you cross the equal sign, it becomes negative. So we have minus 24. Now let's look for two values. When we multiply, we get minus 24. When we combine together, we get minus 10. So here we said, okay, the best two values will be minus 12 and 2. Minus 12 times 2 will give me minus 24. Minus 12 plus 2 will give me minus 10. So we have s minus 12, s plus 2. So our first value, s, will be 12. S equal to 12. And the second value, s plus 2 equal to 0. So s will give me negative 2. So our s value is 12 and negative 2. The same thing, we can check if the answer is correct. Plug 12 to the original equations anywhere you see x. And the left side answer should be the same as the right side. Or plug negative 2 to both anywhere you see x in the equation. The left side answer should be the same as the right side answer. So here they say checking s equal to 12 and s equal to negative 2 is in the original equation. That is again the question. We see that x equal to negative 2 makes the denominator equal to 0. So this means we have only one solution. And actually, let's check it and see what they are saying. So we're going back to the original equation. So if I plug the s value negative 2 here, you see that I'll get everything divided by 0 because negative 2 times 3 will give me negative 6. Negative 6 plus 6 will give me 0. And as we all know, anything divided by 0, there's no solution, undefined. So now let's go to, we have two, again, examples here solving the quadratic equation again using factoring. Now let's use the formula. So the quadratic formula, here we say we can solve quadratic equations of the form x squared equal to 6. And here we say no x10 by taking the square root of both sides. So if my quadratic equation is only x squared equal to any constant value, then I'll take the square root of the constant value and that will give me the x solution. So it will be plus or minus square root of c. C can be any constant value. Other than that, if I have ax squared plus bx plus c equal to 0, then we can use the quadratic formula, which is minus b plus or minus square root of b squared minus 4ac divided by 2a. So a will be the constant value for x squared always. B will be the constant value for the x variable, and c will be the constant value. So again, let's see an example. First, again, we have to understand this term. When we look at the formula here, the square root of b squared minus 4ac. B squared minus 4ac is something we call the discriminant. So here we say that when solving a quadratic equation, we can use the sign of the radicand in the quadratic formula. That is the sign of b squared minus 4ac to determine how many real solutions there are. We refer b squared minus 4ac as a quadratic discriminant. So for example, if the b squared minus 4ac is greater than 0, then the equation will have two distinct real solutions, which means we get two values for x. Now, if it's equal to 0, then we get only one solution. We get only one value for x. And if it's less than 0, there's no solution. Why? Because again, here we are dealing with real numbers, not complex numbers. So any value, square root of a negative value, there's no solution. There's no answer. So again, b squared minus 4ac. If the answer you get here equal to 0, that means we get only one solution, one s value. If it's greater than 0, then you get two answers, two distinct s values. Now, if it's less than 0, which is negative value, then you get no solution for the equation. So let's see an example. So here we have a function. Normally, these are some of the good examples of using quadratic formula. Now, if I have b equal to negative 1.057 t squared plus 8.259 t plus 74.071, well, this decimal value will be very difficult to use factoring. And to factor is very difficult because decimal values. So yeah, I can just look at the equation and say, okay, t squared, that means negative 1.057 is a. T, that means 8.259 is b. This is a constant value, so c will be 74.071. So we just plug these values into the quadratic formula and find the solution. And that's what we do here. So we have our a value, we have the b value. The a value is the coefficient of t squared. The b value is the coefficient of t, and c was the constant value. So we plug in the value. The formula again is minus b plus or minus square root of b squared minus 4ac divided by 2a. So when we plug the value for b is 8.259. And we have b squared, so we also have 8.259 squared minus 4 times a, which is negative 1.057, times c, which is 74.071, all divided by 2 times a. Again, a is negative 1.057. So again, we do our arithmetic operations here, and this is what we get. Negative 8.259 plus or minus everything the square root values expression gives us 381.383. So this value is greater than 0, so we're going to get two distinct x values. We multiply 2 by negative 1.057, we get negative 2.114. So after the arithmetic operation, We find the square root, we get 19.529. That's the square root of 381.383. So our final answer will be negative 8.259 plus 19.529 divided by negative 2.114. The second S value will be negative 8.259 minus 19.529 divided by negative 2.114. And that's what we have here. So this is our first T value. And the solution is approximately 13.145. And the second value. And the second value, we will get a positive. And what will happen is that the second value, you can see that if we have plus 19.529, we will get a positive value divided by negative. So the answer will be negative. And this is an application problem, which is based on time. And we know a time cannot be negative value because the question said, this equation given to us describe a Social Security Trust Fund balance B in billions of dollars when T is the number of years. So T value cannot be negative. So that's why here we ignore. Again, the rule said that if the discriminant is greater than 0, in this case it's 381.383. Yes, so we get two values. But this is an application problem based on time. T is time. So if we get a negative time, this means it will be 13 years. And the second value will be negative, so we ignore that. So here we say, therefore, the trust fund balance is projected to reach 0, slightly more than 13 years after 2000, during the year of 2014. So here we say the x-intercept is also the value of s that makes the function 0. And this is called the 0 of the function. S-intercept means the value of y is 0, and this is the function. So because the value and this value of x makes f at s equal to 0, it's also a solution or root of the equation, which is 0 equal to f at x. Also, we can solve quadratic equation formula by using, again, a graph. So for example, we graph our equation, and this is what we get. I find the solution of this by graphing, and we can see the intercept when y equal to 0, the value of x. So here s equal to 2. And the other section, when s is 0.28571, y is 0. So we get two solutions for x. So again, that will be the conclusion of our lectures, which cover again chapter 2, section 1. Again, I'm using the course textbook slides. So next lectures will be chapter 2-2. Again, in these lectures, we learn how to solve quadratic equation, both by using factoring method or by using the quadratic formula. Again, wish everybody the best, and thank you. If you have any question, again, send an email. Thank you.